Hey guys, welcome to class. Today we're going to be doing Unit 3, Lesson 1, which is Linear Relationships. We're going to be looking at the Desmo slide, so hopefully you're logged in and ready to go. Remember, all information that is on this video is purely for Laurel Middle School students. Before we get started, make sure that you have answered the attendance question in Schoology. You have your student workbook, a pencil, and paper for notes if you don't have your workbook. The goals for this lesson are to create graphs and equations of proportional relationships in context with an appropriate scale. Interpret graphs of proportional relationships in context. This is a notice and wonder. This is your warm-up. What are some things you notice? What are some things you wonder? Feel free to pause me while you ponder. So, some things that you might have noticed or some things you might have wondered. I wonder why the first graph has 2 lines and the second one has only 1 line. I noticed that in the first graph that the scales are labeled. My x and y axis have labels. I also noticed that in both graphs they counted the same number of intervals on both the x-axis and the y-axis. As we move into Activity 1, I'd like for you to look at the diagram. In the diagram, there are 2 different types of bugs shown. One's a ladybug, one's an ant. The ladybug is showing measurement for this by the front of her head, while the ant is using its measurement by the front of its antenna, or the receptors there. So make sure, as you count your tick marks, that you are measuring from the right portion of the bug, or the right section of the bug. So it says here that each tick marks represents 1 centimeter. So what are some things you can tell right away by looking at the diagram? Feel free to pause me and see what you can determine before we go over it. Some things I notice is that the ant has traveled 4 centimeters at this point. I'm sorry, the ladybug has gone 4 centimeters. The ant has gone 6 centimeters. And in the next diagram, the ladybug has traveled 8 centimeters, while the ant has traveled 12 centimeters. Then in the next line of data, it shows that the ladybug is at 12 centimeters and the ant is at 18 centimeters. Some things you might have determined already by looking at this diagram is that at 0 seconds, the bugs have traveled 0 centimeters. Again, in the next line, it shows that the ladybug in 2 seconds and the ant traveled 6 centimeters in 2 seconds. Then I have another set of data. The ladybug in the next line, centimeters in 4 seconds, while the ant, some things I could determine already. Obviously, the ant is traveling a little faster than the ladybug. The ladybug seems to be a little bit slower than the ant. In the next diagram, I'm giving you a graph. The x-axis is labeled with distance traveled in centimeters, and the y-axis is labeled in time in seconds. Which line is showing the ant's movement? Which one is showing the ladybug's movement? Pause me and have a look at the graph and see if you can figure out which line is which bug. If you determined that the line for the ladybug is line U, you would be correct. And line V is the ant. Some reasons that you may have come up with. I used the intervals and the line. So by looking at the intervals of how I would count, I would see 1, 2, 3, 4. So at 4 centimeters, I have 2 seconds if I were counting by ones here. So I can help myself determine what point would be for each of the bugs just by looking at the diagram. It says, how long does it take the ladybug to travel 12 centimeters? The ant. Pause me for just a moment. See if you can figure out or remember by going back and looking at your previous diagram. If you said it took 12 centimeters and 6 seconds for the ladybug, you would be correct. Oops. And if you also said that 12 centimeters for the ant was done in 4 seconds, you would be correct. And that is for the ant. I think I'm moving faster than my pen wants me to move. So if I can determine that the ant is going 12 centimeters in 4 seconds and the ladybug is doing 12 centimeters in 6 seconds, could you determine the speed of each of these bugs using only a single unit? What would the unit rate be?